Well, welcome everyone to, I just forgot the title of it, Validation in an Eventually Consistent World. We're going to talk about validation in the context of microservices. So let's get into that. I'm Ethan Garofolo. I help companies use microservices for my day job. And if you want to email me about it afterwards, there's my email address. Okay, but we need to give some context to the subject here, okay? That's no moon, that is a Venn diagram. And so in the context, there's the broader subject of microservices. Validation is one small part of that. So we need to get a little bit of broader context before diving into the validation aspect of it. So a service-based architecture is in contrast to the monolith. This is an example of what a monolith might look like. Database in the center, all the things are wound together, entangled, and communication happens implicitly at the database level. And most MVC frameworks will push you in this direction. They're not bad for prototyping, but I'd hope that we're expecting our systems to last longer than 15 minutes. And so this is just a monolith, all in one program, if you will. And it has its less pleasant associate, the distributed monolith, which is where you take components out of it and just stand them up on a different server. You've left intact all of the coupling that makes working with a monolith difficult. And now you've also changed function calls into HTTP calls. So now you have to deal with all the associated error handling and all that, as well as the greater ops concerns of having additional servers. So we don't want to do that. And this is not the context we're talking about today. This is kind of what I think working on a monolith is like. Have any of you ever done a bungee run before? Okay, not everyone. It's really cool. You get on this bounce house, essentially. You hook up a bungee cord to your back, and you start running. And when you start, you're going really fast at first. But then that bungee cord starts getting stretched out, and you get to a point where you stop and jump and go flying backwards, and that's a lot of fun. And maybe in our career context, that's when you apply for a new job or something. I don't know. But monoliths reach a very difficult point where it's really hard to work on them. Distributed monoliths too. We're talking about microservices though, so enough on the monolith. So what is it that defines a service? If you have a system with a number of different software components, what is it that says this thing is a service, this thing is not? I submit that the thing that determines that is whether or not the component is autonomous. So a service, for example, would not ask questions of anything else in the system. If it did that, it would no longer be autonomous because it would be dependent on those other things. And if those other things were down, the system would also be down. Also, no one asks a service for anything. If you ask a question of something, that thing is a database, not a service. Databases are fine pieces of technology. They're just not services. Also, services are pretty much oblivious to the existence of everything else in the system. They just have a basic communication channel, an event store of some kind, and that is their entire view of the outside world. Messages come in on it, they publish new messages going out on that same thing. That communication is handled asynchronously, and there are two flavors. There's events and commands. So here's an example event of type pen dropped. I brought a prop to this talk, it's exciting. I have this pen, I can drop it, and now reality has registered a pen dropped event. That's pretty exciting, huh? Notice that its type is past tense, and you have to deal with events. You don't get to argue with them, they just are. I can't argue about the fact that this pen is on the ground. If I don't like it, I can pick it up, but now I've emitted a new pen picked up event. The history is still that the pen was dropped and then it was picked up. Commands, on the other hand, are in the imperative tense. You're telling a service to do something. It can say yes or no. So for invalid commands, Drake has become a theme at the conference today. Anyway, you can reject invalid commands. Valid commands you let through. And structurally, they look very similar. I'm just representing them as JSON objects here, and that's fine. But the events in these systems are literally the state of the system. They're not just a cool log of what has happened. They are literally the state. So on the left, there are the two events, pen dropped, pen picked up. That is the real state of the system, not this rolled up version of it on the right. I can derive this thing on the right from processing those events, from handling them, but that is the authoritative state on the left, and on the right is just a projection of that state. That's that. Next is the basic shape. What are the overall components that you'd see in a system like this? Obviously, there are the services. I represent them with lightning bolts because that's action-packed, and services are the doers of things. Your users, who are of course happy, they don't have direct access to the services. So there's probably some application layer that sits between them and the services. It's called an application because it applies services to accomplish some task. It issues commands to the services and also sends data to the users via whatever sort of interface you have. If it's going to send data to the users, it needs to get data from somewhere. And those are from read models. You could have more than one. So that event stream that we saw a few slides ago, where I just projected that into this pens table with a status, I could have other read models. Suppose you have the concept of users in your system, which is pretty common, and you wanted to explore relationships between the users. Well, relational databases, they're not great at modeling graphs. So in a system like this, I could take the list of events and project them into a graph database, which would be much more suited for that kind of exploration. So I'm not limited to just having one, which I think is a big win. So if the read models are then going to give data to the application, the data needs to get put there somehow. And so there's a final concept here called aggregators. They observe the events, and they're the ones that actually write the data into the read models. And this sort of overall system, I know this is like a fire hose of it all, is the basic structure that we're looking at, and really important for moving on from here. So are there any questions at this point? Okay, we're going to move on then. Oh, yes?
Sorry. So events happen on a queue and stuff. The aggregators, they're just subscribing to this queue. Is that the idea?
That's right. Mm-hmm. The question was, the events they're being published somewhere, queue, event bus, an event store, whatever you want to call it. The aggregators are just listening to those events and then writing things into these read models that can then be picked up by the application to send to users. You notice that the data flow is unidirectional, so if you like React, this might feel more comfortable. But one last important thing, none of this setup implies that this system is actually a distributed system. The deployment strategy has nothing to do with whether or not it's a service implementation. You could have all this running inside of the same program. If you want greater availability, you might distribute, because I have a collection of 3 services up there. If one of them goes down, I don't want the whole system to go down, which is what would happen in a monolith. But in a services-based implementation, especially if the services are distributed, if one of them goes down, you probably won't be able to accomplish the work in the system that you're trying to do, but you still won't see the 500 page when you're trying to load it up, and that's a win. Okay, next, I have to give an apology. I've been to a number of talks and conferences and meetups in my years, and sometimes you go there, they present some cool library or the answer to what you're trying to figure out. If you came here looking for the answer, I'm sorry, I don't have one of those, because there is no one answer for every system. All we can really do is try to figure out what questions we should ask to find out the right answers for our system. Even within a particular system, and incidentally, I get paid on how many times I say the word system. Even within the same project, different types of data may need validation in different places. And so that's really what we want to do, is start asking ourselves the questions, how do we do this correctly? So we're going to do that by looking at some specific scenarios that would likely come up in a real-world project. And let's consider the first one. Registration. You want your users to have unique email addresses. Seems pretty reasonable. Why this is a challenge? Remember, this is an eventually consistent system. So what that means, if you're not familiar with the term, is normally, say if you're dealing with a Postgres database, you write some query to it. When that has returned in your program, the result of that query is immediately available. Like right now, you don't have to wait for it. In contrast, when the application issues a command, there is a delay before a read could pick up the result of that. And so if you're trying to guarantee uniqueness of email addresses, that delay could be a problem. So basically, we have to pick some place in this map where the validation logic is going to live for this particular problem that we have. So a first big question we can ask ourselves, how likely is the thing we're trying to protect against? So keep that question. When we're validating, we're trying to prevent something from happening. How likely is that thing to happen? So keep that in mind as we go into this. One possibility is we just use the eventually consistent store. A user registration request comes in, and the application layer just asks the read layer, hey, has this email address been used before? Read layer says yes or no. We go on our merry way and handle it appropriately or accordingly. And that has some pros. That's really simple. How many of us feel confident that we could write a database query? Yeah, that's right. It's not hard. Doesn't violate any of the core principles of a microservice-based system because the data flow is still going in the right way. We haven't reached across odd boundaries. Components haven't gathered knowledge that they shouldn't be allowed to have. But it does have some cons. Remember, that story is eventually consistent, so we've got a potential race condition, right? A command could come in to register a user with one particular email address. While that's being processed, another one comes in with the same email address. That's scary. But here's the thing. Eventually consistent does not mean that someone in our data center attaches a piece of paper to a carrier pigeon and sends it off who's going to fly to another state. We're not talking about delays of days and weeks. We're talking 100 milliseconds. So I'd say that that's fine. What is really the likelihood that two requests to register with the exact same email address are going to hit within a window of 100 milliseconds? That might not be satisfying, though. So the next big question, how big of a deal is the thing that we're trying to prevent? In the case of the email addresses, what really would happen if we got two registrations with the same email address? Let's talk through that one. So just because we're using microservices doesn't mean that we're not taking advantage of the features that our read models have. Those could be simple Postgres database, MySQL, or whatever. And those kinds of databases have unique column constraints. We would still use those. So we can push this problem off to the aggregator. So here is the first registration that comes in. The event type is user registered. Does my mouse show up there? Oh, cool. Not that it's helpful because it's hard to see. Anyway, the type is user registered. It has that email address, blah, blah, blah. Hits the aggregator. The aggregator is going to project that into a read model that the application can use. This may not be readable, but it's just a GUID. That's how we'd identify things in a system like this. And the projection of this event is that in this table, there's now a record with an email address called dupe@example.com. So then the next one comes in, trying to use the same email address. We have a different ID for it, so we can still uniquely identify the records. But when the aggregator goes to write this new row, it's going to blow up because we have a unique constraint on that column. We can't have the same email address listed in there. Well, what if we relaxed that constraint and said, let's go ahead and allow the write to happen? Thing is, there's probably going to be a password hash or some other way to uniquely identify a user logging in. And so what is authentication if it's not a query? Find me a user whose ID is this and whose hashed password is this. I could run that query and uniquely identify those two rows, so not a big deal. But then I can add another column to this thing saying, needs to change email. So when these events are coming through the aggregator, the first one just gets written normally, but the second one, the duplication is noticed, and we just set a flag that this email address needs to change. So the aggregator has solved this problem for us in conjunction with a little bit of UI work, that when the second user logs in, we pop them a screen that says, hey, you need to change your email address. That might seem convoluted, I'll admit that, but we got to remember why we would even take this approach in the first place. Remember the bungee run. We don't want that. There's a lot of simplicity that the monolith gives us, but it introduces a lot of problems too as systems get larger and more complex. We are losing a little bit of that simplicity to gain a whole lot of future growth for the system. So we have a duplicate email address here, and it just is not a big deal. We can easily handle that. And maybe the aggregator is also keeping account of how often it sees these duplicates. Because again, we're talking about a really narrow window for two people to try to register with the exact same email address. It's probably not a problem, but if we keep account, we can figure out how bad of a problem it is. And if it turns out that this is happening 30 times an hour, well, maybe then we can devote some scarce engineering resources to dealing with it. Whereas otherwise, we can just, yeah, whatever, it's not a big deal. If you do find yourself in the position, though, where you really cannot has any duplicates at any point, and there's a 1 in there on purpose to emphasize how important this is, you can just push that off to the services. So remember, services are autonomous. They don't ask anything else for information, but they are observing the flow of events. And if they need state to do their job, they're responsible for maintaining that state. So they can just look at the event stream and say, hey, has a user with this email address registered before? They probably wouldn't want to do that on the fly because of implementation reasons why that would be slow. So maybe they just load up a list of that at startup and push it into Redis or something. But we can't just let the services, when they receive the command, say, nope, sorry, this is a duplicate. I'll take nope for 800, Alex. You probably wouldn't want to actually name your event type that, but. So those are 3 different ways of handling the validation of this one particular case of we want unique email addresses. Which one is correct? I don't know. Depends on your system. If you are Facebook at that sort of scale and getting user registrations constantly, although I don't know if they are anymore because there's a limit to how many people are on the planet, then this might be a bigger deal than it is for, say, I don't know, a hobby project. So those are some questions to consider. Next scenario. Next scenario. Pretend you're an e-commerce store and you receive an order and you want to make sure that you can fulfill that order. Leads us to big question number 3. What does correct even mean? So that's the question we want to keep in mind. We could do similar to the first scenario. Order comes in, we check our read models to see if we have inventory available, and if we do, we allow the order. If we don't, we reject it. And that has some pros. It's, again, simple. You probably won't end up taking customer money that you'll then just have to refund. It's immediate, but it kind of has a big negative to it. You're sending customers away. Don't send your customers away. How many of you, if you went to a website, you tried to order a product, and they popped a screen that said, sorry, we're out, try again later? How many of you would try again later? I'm not seeing any hands. What would you do? You just go to a competitor's website, unless it was some crazy specialty item, but I don't know. I've never bought something like that online. So you're basically just helping your competitors if you adopt that way of dealing with it. So maybe that's not correct. Maybe it doesn't matter. We could use the services to do this validation and sort of stretch the validation out over time. So for example, in phase 1 of it, we want to make sure, I don't know, something superficial like this isn't a toxic customer. By that I mean the person who buys stuff and then sends it back and then complains about it and constantly emails customer support. We don't want to accept orders from that because that's just kind of a headache. So it passes that, it moves on to some sort of a fulfillment service. And so some worker and their robot friends will be going to the warehouse actually to get the goods to put in a box. And at that point, maybe there aren't any items in stock, even though that the initial check said there was. This introduces a new idea, the system of record. If you're not familiar with it, here is a blurb from Wikipedia. If you don't want to read it, the short version is the system of record is the authoritative source of the state of things. So if you're in the e-commerce business, shipping physical goods, what is your system of record? What was that? Exactly, the warehouse. Your computer system may say you have 5 pens in stock, but if you go to the shelf and there are 0, you actually have 0 pens in stock. And so you got to deal with that. And so in phase 3, the outcome, when the people go to fulfill the orders, maybe on day 1 they say, oh, we don't have any in stock, and an event gets emitted saying that the order was, okay, not that far yet. There might something that says order not fulfilled. Day 2, same thing. Day 3, some business rule determines how many days we're willing to try to fulfill this before we give up and just reject it and say out of stock and tell the users about it and everyone's sad. Or maybe after 2 not being able to fulfill it on the 3rd day, there are suddenly 5 pens in stock and you can fulfill the order. And so upon seeing the rejection, how do you handle it? I don't know. Maybe you rush order more inventory because it's that important that people have this particular kind of pen, and you can involve the user if you want to. And so, I mean, just again, the answer is that you need to think about it and determine what is correct for your system. The last scenario here, and we have about 5 minutes left, payment processing. Suppose you want to receive money for the things that you ship to people. So the application layer might receive a payload from a browser, for example, that contains all the things I want to buy and credit card information, because maybe I'm checking out as a guest or I'm a first-time user of the system. So I could just, in the application layer, fire off a charge request to the payment provider. But I don't know, I don't like doing that sort of thing in the middle of a request response cycle. That's why there's the exclamation point, because that's bad. And then also the application starts to get to know too much. And while technically not a monolith, it's acquiring some of the properties of a monolith. I could push that into the services and have a service that deals with it. That seems nice. And maybe the service tries to run the payment and it fails. And so if it fails, we can just issue the payment rejection at that point, because that's the point at which the order is no longer valid. We can kick off a sequence that involves the user saying, hey, you need to update your payment information, or maybe it all works and we move along to the next state. Big question number 4, what type of validation are we trying to do here? There's a nice article there that's linked in the slides. It suggests there are 2 different kinds. There's superficial and domain validation. Superficial would be things like typos. Maybe you entered a social security number with 5 numbers in it. That's not correct, or you didn't type in an email address correctly. Domain validation are things that are specific to the system, though, like your business. Can an order be canceled after it has been put in a box? Maybe we want to allow that because that provides a better user experience. It'd be costly on our side, but it might be worth it. If it's a learning system, like an LMS of some sort, should we allow students to add answers to assignments that have already been collected by the teacher? So there are these different kinds of validation we need to worry about as well. And then lastly, should high school kids be allowed to launch the nukes? I was thinking of war games, but... So when I'm thinking about the different types of validation, if I'm thinking, oh, where does the validation live, in the application or the services, we can come back to our friend here. Why not both? Why not have the application deal with the superficial stuff, and then have the service deal with the non-superficial stuff, the actual domain validation, and we can end up with the same outcomes. And we've sort of put things maybe in appropriate places. And those are the scenarios. So the grand answer of how do you validate things in an eventually consistent world, an evented microservice-based system, the answer is there is no single answer. There are some questions that might help us think about what's right for our system for this particular case, and they're listed there. But some other things to keep in mind is assume less and consciously decide more. Talk to your business team. I think as developers, we tend to have ways we've always done things and we keep doing them because that's the way we've always done them. Those assumptions aren't necessarily correct, and we want to foster communication with everyone involved with the project to help avoid that. And here's a dirty little secret. I don't really think any of the scenarios we've talked about are introduced by having a microservice-based system. We had them anyway. It's just eventual consistency forced us to talk about it more and consider it sooner. So, I mean, you could pull off all those same flows, even with the order stuff in a monolith, but you might not think to because you have a readily available answer to, do I have any more things in stock? If you want to learn more, send me an email. Seriously, emails are fun. Here's some good people on Twitter to follow. The slides will get posted somewhere, so if you don't want to copy all this down, you can get it there. And happy coding. Thanks for coming.